I'm going to do another question from May Leetcoding challenge. Today's question is called cousins in binary tree. So let's go ahead and read the question together. So in a binary tree, the root node is a depth 0, and children of each depth k node at depth k plus 1. Okay, so let's say that this node, like node 1 right here, the depth would be 0, and the children of this node would be depth of 0 plus 1, which is k plus 1. So that makes sense. And two nodes of binary tree are cousins if they have the same depth but have different parents. So there are two requirements to be a cousins. One is they need to be like the same depth. Second is they have different parents. And we are given the root of a binary tree with unique values. And so this is a key, unique values. And the values x and y of two different nodes in the tree. And so the root is basically like a nodes. So given a node, so this is a node, and x and y's are integers. Return true if and only if node corresponding to the value x and y are cousin. So this question is, I think, kind of like want to test you to see if you know how to like traverse through the tree. And like as we traverse through the tree, we need to gather like some information. Like one of the information is you need to figure out like the depth of each node, and also like the parent of each node as well, because like those are the two information that we need in order to determine if two nodes are cousins or not. Alright, so we can look at this example. So we want to know if 4 and 3 are cousins. So since 4 is right here and 3 is right here, they are not cousins because like 3 is at depth 1, because we started 0 right here and then 1 right here. And so 3 have depth of 1, but 4 have depth of 2. So 2 is not equal to 1. So it made this criteria right here, the same depth, invalid. So it's not a cousin. So we're supposed to return false. And okay, let's look at this one. So for this one, they are false, even though they are at the same depth. So 2 and 3 have a depth of 1. However, they share the same parent, so it makes it invalid. And on top of that, we also know that the number of nodes in the tree will be between 2 and 100, and each node have a unique integer value from 1 to 100. So we can look at the example that we're supposed to return true. So for example, like this question 1. So we're looking at nodes 5 and 4. So node 4 have a depth of 2, and node 5 also have a depth of 2 as well, and they share different parent. Node 4 have a parent of 2, node 5 have a parent of 3. So that's why they are cousin, and we want to just return true. So let's go ahead and think about it a little bit. So first we need to get information from the binary tree. So there are 3 information that we need to find. One is the depth of each nodes. And second is the parents of each node. I mean, like during the interview, you can ask the interviewer other questions. Like, for example, like, are we guaranteed that the the, the node that we want to check is in the tree? That's like one question you can ask. Like, will like 4 be part of this tree? Like, can be 4? Can we like, um, can we like live out 4? Is that the case? If that's the case, it kind of change the complex of the problem a little bit. And the other question is like they already told us that each nodes are uniquely different, so that's good. So that helps us a lot. And so in order like to code this, what we want to do is we need to like gather all this information. So in order to gather that information, we need to traverse through the tree. And let's see. So we can write a function called define traverse tree. So what we need is we need the current root and also maybe some sort of like cache that in this cache it will like store the information of this two node and store this information of this two node and those information are the depth of them and also like the parent of them. So what we want to do is first we want, since there is a like one directional tree, so we need to also like pass the parent as well. So parent value. So initially the parent value is none because like the root doesn't have any parents, and so we don't want to store it. What we want to store is we want to check if current dot value f x or current dot value, is it dot value? Yeah, dot value is equal to y. So whenever we traverse through a node and we found out that that particular node have the same value as x and y, we want to like get the information of that. So first thing is we want to get the information of so we need to do like visited, no, not visited, cache. So cache is a dictionary, so we need to provide, I think we need to separate this out. We can do this, current value. So we know that current value is either x or y. And then once we know that, we want to store like the two information that we want to know. So the first is like parent values. Second is like the depth. Oh, and also like the depth as well. So depth. Right. So this is like the base case of this recursion, traverse tree. I spelled it wrong. Yeah. And if not, so we want to go left. No, we want to visit. Let's do a pre-order. So in pre-order, we need to do pre-order. So pre-order, we need to do visit, go left and go right. So this is like the visit. We check if that is true or not, and I think we should check another case. So the other case is, so before we can like check current value, we need to make sure that the current is not none. So if the current is none, we want to return, and then we can like traverse through traverse tree, can go left. So now we are like safely can go left, could go right without thinking if the left or right tree is valid or not. And the reason is because we have a statement right here that catch that issue. So we need to provide current.left, which is the left child, and then cache. And then parent value would be current.value, and then the tab would be +1. And traverse tree. Right. So this looks good. So we visit, we go left, and then we go right, and then assuming that the value x and y is exists in the tree, we can guarantee that we will get a 2 value into this cache. So like for the main function, what we want to do is we want to pass the value. So first we need to create the dictionary. So cache is equal to the dictionary. And second is we need to hold out the tab. So tab is 0, and then parent value is would be -1. So like this is like the root parent value. So like, since root doesn't have parent, so just like put -1 right there. And then we want to return. Then we want to call traverse tree, and then current would be just the root. Then so it's just root. Then for cache would be just cache, and parent value would be parent value, and then that would be 0. I guess we don't even need this. I mean, it's helped us like to make the code like more readable. And then we check, and now our cache is updated. So after we run this function, our cache should be updated. So since our cache is updated, what we want to do is we want to check so first we want to get the information of x nodes. So x node is we can do is cache, and then the value of x. So this will return us this information, like the array of the parent value and the depth. And y node is the same thing, cache y. So this will give us the information of parent value and depth. So what we want to do is we want to check if, so according to the criteria to be a constant, we need to check that if x node parents are not the same. So this will give me the parent's value, and we want to make sure that it's different from the parent value of y. And also we want to make sure that that is the same. So it would be the first, like the second index. And return true. Otherwise returns false. Alright, just go through the algorithm one more time. So first we need to traverse through the tree to get information and put it into the cache. And there's like 2 information that we want to know. One is the depth of not each node of x and y nodes. Same thing with here, and who is the parent of x and y nodes. So by calling this function, this traverse tree will traverse through the tree, and once it found once it finds x and y, we record the information of x and y. And then, like, once we get the information of x and y, we want to check if their parents' value and their depth. So if their parent value are different, and if their depth is the same or not. So this is their depth, this is their parent value. So it looks good. Let's go ahead and run the code. So it's false. So this is false. I got this right, and let's go ahead and submit the code. So there we go. We got the right answer, and let's talk about the time complexity a little bit. So for this problem, we'll be talking about the time complexity. It would be ONs because we need to traverse to every single node in this tree. So that makes sense. And talking about the space complexity, we create this cache. So this cache is only stored at 2 values. So it shouldn't would take like all 2, I would say. And talking about this recursive function, the time complexity is ON, but space complexity would be, since this is recursive, it's going to kind of do like that first search. So it's basically the maximum amount of recursion would be equal to the maximum length of the binary search tree, or the maximum depth, because every time we reach the depth, like the bottom of the tree, we go up. So it's not O of n. So the space complexity is basically O of the depth of the whole tree. So that's about it, guys. If you have any questions, please feel free to ask me down below in the comment section. I'll try my best to answer all of them. Thank you for watching. Bye.